Welcome. Today we'll prove the trigonometric identity that sine of x minus pi over 2 equals negative cosine of x. Let's write out what we're trying to prove. To prove this, we'll use the angle addition formula for sine. The formula states that sine of a minus b equals sine of a times cosine of b minus cosine of a times sine of b. In our case, a equals x and b equals pi over 2. Let's substitute these values into the formula. Now let's recall two important special angle values. The cosine of pi over 2 equals 0, and the sine of pi over 2 equals 1. Let's visualize why these values are true on the unit circle. When we have an angle of pi over 2 or 90 degrees, the point is at the top of the circle. At this point, the x-coordinate, which represents cosine, is 0, and the y-coordinate, which represents sine, is 1. Let's substitute these values back into our equation. When we substitute 0 for cosine of pi over 2 and 1 for sine of pi over 2, our equation becomes sine of x times 0 minus cosine of x times 1. Now let's simplify. Sine of x times 0 equals 0, and negative cosine of x times 1 equals negative cosine of x. Therefore, we have proven that sine of x minus pi over 2 equals negative cosine of x. This is a powerful identity that shows how shifting a sine function to the left by pi over 2 radians gives us the negative of the cosine function. And that completes our proof. We use the angle addition formula for sine and our knowledge of special angles to prove this important trigonometric identity.